Hello everyone, this is Rupal Gupta and you are watching mathematics classes. Today we will solve question number 6 to question number 10 of exercise 2.3 from chapter 2. Question number 6. 8x plus 4 equals to 3 in the bracket x minus 1 plus 7. Here 3x minus 1 can be written as 3x minus 3. Now हम वेरिएबल्स को लेफ्ट हैंड साइड ले जाएंगे एंड कांस्टेंट को राइट हैंड साइड. सो वी गेट 8x minus 3x equals to minus 3 plus 7 minus 4. We will get 5x equal to minus 7 plus 7. यहाँ 7 से 7 कैंसल हो जाएगा. So 5x equals to 0. Again, dividing both sides by 5, we get x equals to 0. Now, check this solution whether it is correct or not. In left hand side, we have 8x plus 4. Now, put the value of x equals to 0. We get 8 into 0 plus 4, which is equals to 4. So, this is our LHS. Now, take right hand side. 3x minus 1 plus 7. Again, put the value of x 0. We will get 3 in the bracket 0 minus 1 plus 7, which is minus 3 plus 7 becomes 4. यहाँ हमारा LHS and RHS दोनों इक्वल है. So, our result is correct. Now comes to question number 7. X equals to 4 by 5 in the bracket x plus 10. यहाँ दोनों साइड हम 5 से मल्टीप्लाई करेंगे. So we get 5x equals to 4 in the bracket x plus 10. Here 4x plus 10 can be written as 4x plus 40. हम 4x को लेफ्ट हैंड साइड ले जाएंगे तो हमें मिलेगा 5x minus 4x equals to 40, which becomes x equals to 40. Now check the solution. In the left hand side, x equals to 40 and in the right hand side 4 by 5 x plus 10. यहाँ हम x की वैल्यू 40 पुट करेंगे तो हमें मिलेगा 4 by 5 40 plus 10. So we will get 40. यहाँ LHS RHS के इक्वल है. Hence, our result obtained above is correct. Now, question number 8 of exercise 2.3 is 2x by 3 plus 1 equal to 7x by 15 plus 3. We can transpose 7x by 15 to LHS and 1 to RHS. We will get 2x by 3 minus 7x by 15 equals 3 minus 1. Here we can take 15 as a LCM. So this numerator becomes 5 into 2x minus 7x and denominator is 15. After solving it, we will get 3x by 15 equals to 2. After reducing the fraction, we will get x by 5 equals to 2. After multiplying by 5 both sides, we will get x equals to 10. Same question can be solved by another method. As fraction को add and subtract करना difficult होता है, इसलिए जैसा हमने लास्ट वीडियो में सीखा था कि कैसे फ्रैक्शन को होल नंबर में कन्वर्ट कर सकते हैं, फिर फ्रैक्शन को इक्वेशन में हम एलिमिनेट कर सकते हैं. For that, here our fraction is 2 by 3 and 7 by 15. So, we will multiply by a smallest possible number to convert it into a whole number. The number would be least common multiple of 3 and 15, which is 15. So, fraction 2 by 3 becomes 2 by 3 into 15, which is 10, and 7 by 15 after multiplying by 15 becomes 7. Multiply both sides by 15, we get 15 times the whole LHS expression and RHS expression into 15. Now 15 goes into the bracket, so we get 15 into 2x by 3 plus 15 into 1 equal to 7x by 15 into 15 and 3 into 15. After simplifying left and right side, we get 10x plus 15 equal to 7x plus 45. Transposing 7x to LHS and 15 to RHS, we obtain 10x minus 7x equals to 45 minus 15, which becomes 3x equals to 30. Now, to remove 3 from here, let us divide by 3 both sides. We get x equals to 10. So, this is one more method to solve for x. You can choose any method. It will depend on the complexity of the fraction. If the denominator is same, then sometimes it is not needed to go for conversion of fraction into whole number. One such problem is given in question number 9. क्वेश्चन नंबर 9 से हम होल नंबर में कन्वर्ट नहीं करेंगे, फिर भी हम इजीली इक्वेशन को सॉल्व कर सकते हैं. टू चेक दिस सॉल्यूशन, टेक द LHS 2x by 3 plus 1. Put the value of x equal to 10 here. It becomes 2 into 10 by 3 plus 1. We can take the LCM as 3. So after simplifying this calculation, we will get 23 by 3. Let us take the RHS and replace x by 10. We will get 7 into 10 by 15 plus 3. After reducing here, 10 by 15, it is equal to 7 into 2 by 3 plus 3. 7 times of 2 is 14. So, taking LCM of 3 and simplifying this calculation here, we will get it same as LHS, which was equal to 23 by 3. Here, this also reduced to 23 by 3. Hence, solution obtained is correct as LHS and RHS both are equal to each other. Our next question is question number 9. 2y plus 5 by 3 equals to 26 by 3 minus y. Here also we have two fractions, but we need not to do any multiplication. Could you guess why? The reason is that these fractions have the same denominator, so it's already easier to add and subtract them. However, recall that in the previous video, we have this question here also the denominator is same in both fraction, that is 3. But we have solved it by multiplying both sides by 3. Can you guess why? The reason is that in the first question, the both fractions are the constant terms that are going to be added and subtracted together. But here in second question, one fraction is constant and other is the coefficient of y, which is going to add or subtract with 5y. So it is difficult. That is why we have multiplied it by 3. Please do watch our previous video and we have also covered question number 1 to question number 5 of the exercise 2.3. We can simply transpose y to LHS and 5 by 3 to RHS. We get 2y plus y equal to 26 by 3 minus 5 by 3. So 3y equal to 21 by 3, which is equals to 7. So dividing by 3, we get y equals to 7 by 3. We can check the solution by putting the value of y in left hand side. We get 2 into 7 by 3 plus 5 by 3, which becomes 14 by 3 plus 5 by 3 becomes 19 by 3, which is our LHS. Now RHS is 26 by 3 minus y. After putting y equal to 7 by 3, we get 19 by 3, which is equals to LHS. Hence, our solution is correct. Now comes to the last question of exercise 2.3, that is question number 10. 3m equals to 5m minus 8 by 5. Transposing 5m to LHS, we obtain 3m minus 5m equals to minus 8 by 5. Becomes minus 2m equals to minus 8 by 5. Dividing both sides by -2, we will get m equals to 4 by 5. Now check this solution. Here LHS is 3m. So after putting the value of m, we will get 12 by 5. And on right hand side 5m minus 8 by 5. m की वैल्यू हम यहाँ पुट करेंगे तो हमें मिलेगा 12 by 5. यहाँ हम देख सकते हैं हमारा LHS RHS के इक्वल है. Hence, the result obtained above is correct. Thank you for watching the lecture. I hope you understood this exercise. In the next lecture, we will discuss about some more applications of linear equations. Take care. See you soon.